All right, I think we're ready to go. So thanks everyone for joining us today. My name is Andrew Cahil. I'm a research analyst here at The Block, and I'll moderate. The topic of the webinar today is going to be layer ones. I'm sure many are aware of what they are, what they do, but for those who are not, just say two quick things that like every buzzword we're pretty much hearing, whether it be DeFi, stablecoins, NFTs, they all come back to these platforms, and all of these, yeah, it all centers there. And then the second point is really just on the size of the market. So collectively, these platforms are about a $500 billion market cap. So that puts them at about, like 10x the most recent enterprise value on Coinbase. So it's a very sizable chunk of the investable crypto market. And we're very lucky to have four of the people who are the most plugged in the industry to kind of walk us through it and ask some questions with them. So real quick, just to go around, we have Steve Kokinos, who's the CEO at Algorand. We have Anatoly Yakovenko, who's the CEO and co-founder at Solana Labs. We have Emin, who is the CEO and founder at Avalanche. And last but not least, we have Justin Drake, who's a leading researcher at the Ethereum Foundation. So I've learned a ton from all of these guys, and they're at the center of everything. So it'll be a great opportunity. For the format of the webinar, we're going to keep it pretty open-ended. I've got a couple questions to tick through, but we'll kind of see where we go. And then before we get started, I just want to give a big shout out to our sponsors, Algorand and the Algorand Foundation. So they sponsored an in-depth research report that we wrote on the topic, which we're very grateful to have their support. And without them, we wouldn't have been able to do it. And I'd encourage everyone to read it. I think the discussion today might get very technical, and if you find yourself very lost, I think that report would probably be a good place to start. So with that, we'll just go ahead and get started with some introductions. I don't know, Steve, if you want to kick it off and introduce yourself.
Yeah, sure. So I'm Steve Kokinos. I've been I've been with Algorand since early days. I was introduced to Silvio as I kind of started my personal journey around crypto, and I think what kind of struck me was I started my first company when I was 19 in the early days of the internet, and it was the first thing I had seen kind of since that felt like it could have huge impact on people's lives and kind of really represent sort of a new public utility that gets created. And so excited to appreciate you guys doing all that work in the report, and excited to be here and chat with everyone.
Whoever wants to go next, Anatoly, if you want to go next, or.
Hey folks, so super excited to be here as well. Solana is one of the smart contract platforms that's growing really rapidly. Our vision is pretty unique. We wanted to build something that spreads information around the world as fast as possible, and in kind of a programmable environment, build an operating system, at its core. And we see the fruits of that, really demonstrated in the last year, when we've seen lots of developers come in and build new programs, new types of applications running on Solana.
Hi everyone, this is Emin from Avalanche. Let's see. The Avalanche platform is, I believe, the thing that embodies the biggest breakthrough in distributed systems in at least a decade, in the time since Satoshi. The core algorithm gives us the scale that we need to tackle our vision, and our vision is to digitize all things. Every asset should be in digital form. And to facilitate that, we've built a very flexible platform. We understand that assets do not all conform to the same rules, and you need a fabric that can accommodate a variety of different uses. So Avalanche has the notion of subnets that can accommodate many different uses, and our goal is to digitize all of the 72 trillion of assets that's out there on people's books, but not in digital form.
Great. Hi, I'm Justin from the Ethereum Foundation. I've been there since 2017, and I focus mostly on what used to be called, I guess, what some people still call Ethereum 2.0. So mainly proof of stake and the merge. But I'm also interested in kind of the layer 0, which is kind of the community and the people underneath the tech.
Awesome. They're buried, Justin. The people are buried under layer 1.
They're the foundations. Yeah, they're the most important part of the ecosystem.
Awesome. Well, why don't we kick things off by getting right into scaling? So in our research, there's pretty much two distinct approaches that we've seen, kind of people going the multi-chain route and people going the single chain route. So maybe if we could have someone, maybe Justin, if you want to kick things off, given your involvement with ETH2, if you want to just go through kind of the rationale behind the sharded network, would be a good place to start.
Right. So I guess one thing which I think we can all agree on is this concept of shared security. So when you have a system, it's good that every component is under the same system, because as soon as you have different types of security, then you start assuming the worst case scenario, and it introduces complexity and also things like that. In terms of whether we want a monolithic kind of synchronous approach or we want kind of a sharded asynchronous approach, the reason why we've gone for sharded is basically that we have no choice. Like and it's kind of the natural progression of things in computer science, right? You can't do everything on a single core. You need to have multiple cores. If you think of the web, it's fundamentally asynchronous. You're making queries to tons of servers. These servers are themselves making asynchronous queries to databases, and the world is asynchronous, and we need that for scaling, right? We can't do everything synchronously in one monolithic platform. So we're actually embracing this kind of multi-chain approach in two different ways. Like in the short term, we have what we call rollups, which are effectively kind of asynchronous chains, asynchronous to the main EVM. And we have platforms like Optimism and Arbitrum, which are generic rollup platforms, which are going live in a fully open way very, very soon. And then we also have sharding. But I guess you can think of our sharding approach as being very complementary to the rollup. So the real chains, as it were, in this rollup-centric vision are the rollups. The shards are basically just there to provide this fundamental data availability layer, which can be consumed by the shards, by the rollups, I mean. So the shards are not really kind of chains from an application standpoint. They're more like resources that can be consumed for the rollups.
So let me go ahead and share with you our vision for how to build things that scale and are fast. So there are many different performance metrics that people care about or ought to care about. The public, the lay public, typically doesn't know all that much, and they just go with one number, transactions per second. And that is a measure or a metric for throughput. But there are two other things that we should care about. Throughput is one thing. That's transactions per second that you can clear. But finality, time to finality, is very, very important. That is also known as latency. And what you want the time spent from the submission of a transaction to its conclusion to be as quick as possible. And so that is something that we deeply care about. And our platform and protocol are optimized, and they have special unique features that make them the fastest on that front. The third thing that we care about is scale. The system must be able to accommodate as many nodes as possible. Millions and millions of nodes should be able to participate, and it should be able to carry 1 billion users or more on its shoulders. So to do this, you need to innovate at every level, just like Justin said. And all sorts of protocol improvements need to come in. What one cannot do is just essentially recycle old results from 1999 and so on, and give them a little bit of a blockchain makeup and offer them to the public as if they're innovations. So Avalanche, to this end, brings forward a completely different approach to how to do consensus. And it also embodies within it this notion of subnets. So you have parallelism between functionally distinct different networks carrying out different functions. I believe that this is the best way to scale, because unrelated things don't have to consume shared resources. And that allows you to go as fast as possible. So that's the trick behind how we managed to do what I thought when I was in grad school. I thought it was going to be impossible for anybody to match the speed of something like Visa. And to be able to match it in a decentralized fashion is truly difficult. And yet, here we are, this entire space has managed to come up with breakthroughs that disprove the myth that blockchains are forever bound to be really slow inventions that tick along at like 3 transactions per second, and you must necessarily go to layer 2. And let me, since I have the floor just for 1 second more, let me also mention one other thing, because roll-ups got mentioned. Roll-ups, layer 2s, and so forth, these are all wonderful, wonderful ideas. One must always open the field for them to be used. But if you're relying on roll-ups, then you will find that you are always forever going to be limited by your layer 1. Also, a community that relies on roll-ups and layer 2 solutions will forever be a frustrated community. Roll-ups and layer 2s and other solutions typically end up not having a business development plan or a technical or a business vision of their own. They always end up carving out in parasitic form some of the use cases, the juiciest ones of the underlying chain. They, in my view, almost always issue their own coin. They almost always splinter. So I think those kinds of scaling solutions are dead ends and not really desirable as your primary means to scale. What you really must do if you want to be serious in this game and really tackle the trillions of dollars of assets out there, you must have a layer 1 that scales at its core.
I'll just add on to what Emin was saying, which is definitely agree that time to finality is important. And I would just say from TPS, like all the chains represented here, including Ethereum 2, could basically absorb all of the traffic of all the public blockchains in aggregate today. So I think definitely there's scale improvements. I think at the same time, one of the reasons that we really think about, or one of the things that we think about as being critically important, is composability. When you're building financial applications and running smart contracts on them, known state and balances and data need to be certain of that all the time. And when you break off into kind of multiple layer 2 chains, you start to lose that composability, and it makes it very difficult, if not impossible, to build a number of different kinds of applications. And so I think that's something that people need to think about. The other is also looking at, one of the things we think about is where are there places that you can obviate the need for smart contracts entirely. And so we've looked at layer 1 primitives, whether around atomically swapping multiple assets across multi-party, and doing those things in a way that makes it simpler for people. But in addition to that, I think there's sort of composability and speed of the chain, and then there's composability and speed and scale of smart contracts that's important as well. And making sure that smart contracts run kind of at the full native speed of the chain and don't slow the network down, I think is a really key thing. So that's something we focused on as well. And I guess just one other point to kind of layer on this, which I think is a point that Anatoly would agree with, is we think the idea that networks should be making like money from fees is insane, and that if you're only making fees when your network is congested, it means you're earning money when the user experience is the worst. Our point of view is that you need to be expanding kind of the performance envelope over time, and the fees should always be as close to zero as possible. There's reasons they can't be zero in decentralized networks because of certain DOS attacks, but they should be meaningfully close to zero in perpetuity. And I think that all kind of goes hand in hand with some of these, performance characteristics that are key as well.
I guess I'll go last. So, in a lot of ways, similar goals to everyone else, right? We want to build the fastest, cheapest financial network on the planet. I think our implementation is unique in the sense that, we think of the world as one giant network. If we have a node in every ASN and maximize the bandwidth utilization across all those routes, there's nowhere to shard, right? So you kind of just have to build this thing from the ground up to be the fastest possible. And given our background, we're a bunch of ex-Qualcomm guys. The way we look at this is we look at bandwidth and we throw ASICs at this until we can consume all the bandwidth available. And that kind of network is really designed to scale with hardware improvements across all the industries involved. Network bandwidth basically drops by price 50% every 2 years. PCI buses double in bandwidth. Number of cores per GPU, per CPU double in bandwidth every 2 years. And that should translate into price improvements for users, right? If the capacity of the network grows and the cost to maintain that capacity shrinks, then users should get a cheaper and faster and better experience. And that's really the goal for us, is like, how do we build the cheapest, fastest possible censorship-resistant message bus?
Yeah, great. I think one quick thing before we move on to the next topic, maybe Justin, I know if you want to respond a little bit to that, the roll-up question, and kind of how you're thinking about this whole thing, talking to like one system kind of talking to each other across these roll-ups. I know Emin has some concerns about that. If you can quickly respond, and then we'll move on to the next.
Yeah, so one of the things that Emin said was that the roll-ups are parasitic. They don't provide value. I don't think that's totally true, and the reason is because roll-ups have to pay for the data availability. So every time a transaction goes on a roll-up, it has to be made available. That's how you get the shared security, which I think we can all agree is very valuable. And there's a payment for that. And this is kind of different to a Validium, for example, where the data availability is done outside of the layer, but you don't enjoy this shared security. Another thing that I think he said was that maybe I misunderstood, that the roll-ups don't have like a clear business model. From what I understand, they do have a clear business model. One of the things that these roll-ups can do is charge their own fees, for example. So there could be a fee market which is overlaid on top of the fee market for shared security. In terms of the complexities around communication across roll-ups, this is just a fact of life in an asynchronous world, which is the world that we live in. And these things will be technical realities for developers, but they will be abstracted away for the end user. So as an end user, I use my computer, but I have no kind of real appreciation that every time I talk to my hard drive or, my camera or whatever, all of this is asynchronous and abstracted away.
Okay. All right, great. Let's leave it at that. And then why don't we just move on to decentralization? I think it's kind of a word that's thrown around a lot in the blockchain space. It's kind of the center of the whole ecosystem, if you will. So we took a couple stabs at trying to quantify it in our report, but maybe we could just have folks go through. I guess the first question is like why it's important, and then I guess for your projects, are there any things that you're looking at where you can look at and say, hey, we reached this certain point, whether it be number of nodes, distribution of stake, that you think that's like a good point on the decentralization spectrum? Maybe Steve, if you want to go, or Anatoly,
yes.
Go for it. Yeah.
Go ahead.
I can go first. Yeah, this is something that we thought about quite a lot, and really from day one. And the core focus for us is the censorship resistance of messages across the network in real time. And that requires maximizing the minimum set of nodes at up to 33% in classical BFT, because if those all collude, they can basically do reorder events, break order flow. Any financial system that runs on top of it is kind of hijacked by these validators. And increasing the set just requires more hardware, or at least a solution to increase the set requires hardware. And that's the solution that we're really good at executing. So from our perspective, like what I will feel like Solana is fully decentralized is when we have a node in every ESN in the world that has decent bandwidth, we have the capacity to soak up all that bandwidth, and the minimum set of validators that are up to 33% is effectively as large as possible. So the number of independent parties that need to collude to mess with information flow, and therefore all the financial applications that depend on that, is as large as possible. And then I think I can retire. But there's an insurmountable number of problems and to solve to get there, not just on the engineering side, but on the social side, because humans are just really bad at analyzing these things, and they tend to want to just throw their stake to the largest validator that they know, because they trust that one. So those social problems don't have clear solutions yet. We're taking a stab at a couple of them, and we'll see how that works out.
I think just, so kind of adding on to what Anatoly said, or at least maybe taking a step back a little bit. I think if you look at what's going on, the financial world, the decentralized traditional financial world, is one where people manage counterparty risk by knowing the person that they're transacting with, knowing the firm that they're working at, knowing the country that, you know, the set of laws exist in. And in a lot of ways, moving transactions to public blockchain networks means that it's a big shift in counterparty risk. And, you know, I think there's a few things that people should be focused on there. One is understanding at some fundamental level the technology that was created and that the network is based on. I think the second is, you know, is the network controlled by one or a small number of parties, or is it not? And, you know, how do you kind of make sense of that from a technical decentralization standpoint? And then I think there's a third one, which is, you know, what are the quality and security of the smart contract system and the smart contracts themselves? And so I think that's sort of the new paradigm that people need to think about. And I think from, you know, our standpoint, when we try to look at, you know, what decentralization means, I think the first is, you know, technically how many nodes are supporting a network, how many users, assets, applications, how much, you know, what you know, how are things being utilized? And, you know, I think we, along with many others, post a set of metrics on how the network is being used and how that's moved. Totally with Anatoly on is, you know, how, and I think also on with Justin is how much application development activity is there? How many projects are supporting a chain and building around it, and what code repositories are being contributed to, which is a lot more sort of amorphous and I think a little bit more difficult because it's less based on hard data, but I think also something that people need to look into when they're kind of investigating this. But I think if you take a step back, you know, part of this is technical decentralization, nodes running a network, validators, but part of it is community, but all of it is really, I think, representative of a shift in counterparty risk and understanding, you know, what the relative risks are of using a given network.
So in terms of you know, why decentralization is important, I kind of think of it very similar to a seatbelt in the car, right? Most of the time, kind of, you know, you don't need the seatbelt and it's kind of uncomfortable. But, you know, if there's an accident, like the 2 seconds, that's going to be critical to have the seatbelt. So, you know, a lot of the time we don't appreciate decentralization enough is because, you know, like these tail risk events haven't really happened. And, you know, our goal for Ethereum is to try and make it World War III resistant, and try and really push this long tail of events as far as we can. In terms of you know, quantifying the decentralization, you know, we can look at a layer 1 metrics. So, you know, for example, how many clients, you know, are different types of clients are supporting the validator set. And on Ethereum, we're very unique in the sense that, you know, at the Ethereum Foundation, we don't build clients, we build the protocol. And so we have this organic set of client builders, and there's actually 5 different clients nowadays. Another thing which is very nice about Ethereum is that we have you know, a lot of validators, you know, more than 100 times more validators than kind of the second next project, and you can have a look on stakers.info for these kinds of metrics.
All running in the
we're gonna have to talk about that now.
Yeah, let's talk about that.
Can I count every thread and Solana process as a validator?
Yeah, can I? If I use your code, then I have more validators than everybody here, and it's just you're juicing you're goosing the count.
Okay, but I mean, for the validators, we could also look, I guess, at economic security. So we have $21 billion of ETH staked.
If that 100x, do you think that the actual security of the network changes?
Yes, I think so, because right now, $21 billion is peanuts for a nation state like the US government or the Chinese government.
The number of keys, independent users that are securing the network is the same, right? The number of wrenches I need to hit over the head is the same. Does it matter what the value of ETH is?
No, it does, because there's kind of various attacks you can do. Like, one attack is the most naive attack, which is the brute force overwhelming attack, where you just match the equivalent amount of stake that there is right now. You just
I put a Goldman exec in the board of Binance, Coinbase, and Kraken, and I have 33% of the ETH stake.
Yeah, so that's
yeah, 5 subpoenas gets all of that.
Yeah.
So this kind of
ETH too, by the way, it's not ETH. It's ETH too. It's a vision that has not yet really processed a single transaction, right?
So yes, so at the merge, the $21 billion of economic security will be securing Ethereum. That's correct. So we do need to imagine a little bit into the future. But you're right. Like these more sophisticated attacks, which use the fact that there is centralization, for example, in exchanges, definitely do exist. Our defense for that is basically if an attack does happen, then we have a recovery mechanism, which is basically slashing. So the attacker is kind of removed automatically from the system, and the system heals on its own. I guess when thinking about decentralization, I also like thinking about layer 0 decentralization, which is kind of governance, and layer 2 decentralization, because they also affect layer 1. Governance is kind of obvious because that's how layer 1 is changed and upgraded over time. But layer 2 is also important, and we've seen the importance of that for the DAO hack, right? For the DAO hack, there was 11.5 million ETH in a single contract. And the fact that it was not decentralized at the application layer meant that there was systemic risk for the layer underneath, for layer 1. And I think one of the things that we've improved a lot over the 6 years is basically decentralization at the dApp layer. And you can see on DeFi Pulse, like the #1 contract right now is basically Maker, and they only have 2.2 million ETH in that contract.
So let's see. Let me try to sort of start from first principles and give everybody sort of a view of how we measure decentralization. There's a very simple metric. You look at the totality of the system. You find the weakest link, and you determine how many independent actors, how many different things can go wrong independently for that weakest link to compromise the rest of the system. Okay, it's that simple. So Anatoly hinted at this when he was talking about a third of the 33% attack for BFT type systems. That number is variable for Avalanche. We can parameterize the system to withstand all the way up to 49% of the stake being compromised if we so choose. And so that number is very important. There are lots and lots of ways to goose your metrics. Everybody that I know from academics used to do this in academic papers. There are lots of different ways of fluffing up your numbers. The easiest one is, of course, you redefine what a validator is, right? If I define a validator to be a tiny little atom, and I ignore the fact that it takes giant big pieces to actually participate meaningfully, and I can count every atom, I get huge numbers, etc. So that's just dishonest. And the right way to do this is how many independent failures does it take for something for the system to go under? And when we look at that, we easily see that that current protocols are incredibly limited. We must necessarily look at every single decision independently. You can't just say, oh, I have a giant pool from which I select or sub-select some small numbers of participants. That doesn't really work when you do the analysis like this. You got to do bottleneck analysis. If in one decision you are relying on this small set, well, then that small set is your weakest link. And what does it take for that small set to be compromised? So sadly, for the longest time, academics and others could not come up with protocols that could actually scale in the number of participants per decision. Almost everybody needs to essentially play. There's a dilemma. It's not even a trilemma. It's a dilemma, which is as you increase the number of participants in your system, your performance drops. Anatoly can only add so many nodes to his system before the system ends up croaking and the TPS starts dropping because these nodes all need to talk to each other. It's just the nature of the protocols that he uses. I think Anatoly will agree. You can't just arbitrarily add nodes. So as a result, what you end up having is this funky game where you either have very, very small numbers of participants and high performance, or you have relatively higher performance, but you don't have that many participants to the game. So or rather, as you add more participants, the performance drops. So the way out of this is to use entirely different protocols that perform less communication per decision. And for the longest time, we did not have any of these. Okay, so almost every protocol that I know of out there essentially uses all-to-all communication among the validators, order all-to-all, and therefore cannot really scale. Avalanche is the only one that changed this game, period. That's a big, big statement to make. And so once you have that, then suddenly you can add millions and millions of nodes involved in every decision. And that kind of a protocol change is immensely important, because we know now that that law enforcement can send subpoenas to 5 people. It's not a problem. That somebody could show up at 5 locations with a wrench. It's not a problem. And it's essential for the blockchain to be open and to be grown by as many people as possible. So I'm really proud that we now have invented mechanisms that allow us to have millions of participants per decision. And that's the only way to go out. Now, on top of that, all of the other concerns are rock solid. Stake distribution is critical. Community decisions are absolutely essential. And on that front, nothing parallels Ethereum. I am in awe of that community and the way they make decisions. They have a fantastic way of making decisions in a decentralized fashion. So there are lots of different things. And what one has to do, as always, is to do essentially what is known as the Nakamoto coefficient, which is look at the entirety of the thing and find the weakest link. If the weakest link is in the community, then that's what you go after. But at the moment, it seems that every single one of the systems out there is limited at the technical level because they're performing all-to-all communication at their protocol levels. And that's the reason why they cannot scale.
So I would argue in the last bit, the cannot scale part, because all-to-all communication is not that big of a deal. It's just every node needs to process end messages. There's absurd amount of bandwidth and absurd amount of cores, an absurd amount of ASICs you can throw at this problem. You can increase IO ops. You can parallelize this in every dimension. And the cost of doing so drops by 50% every 2 years. So when we're talking about a span of 20 years, it's 1,000x improvement. And at some point, these systems are going to be powerful enough to handle all the world's financial applications, and the demand is only going to grow with GDP, right? But Moore's law is still going to continue marching on, because if it stops, the only coin we should be working on is bunker coin.
Well, I think there are lots of different ways of looking at this. I keep being told that the Lightning Network will solve all my problems. I just have to wait 18 months, and I have to wait for certain protocols to come online. Then then all my problems will be solved. If I have to wait, then I don't know. I'm here to solve
100,000 validators. All-to-all communication can fit in 400 Mbps, which is a 20-year-old standard.
I think separate from what you guys are, so I think there's like valid points here. I think one thing is like separating network traffic from selection of a block, and having those two things distinct, and then also having part of the security model, both whether you can attack the network or not are kind of important things. And I think we're like all kind of like separating these things in like slightly different ways. I think in Algorand, the size of the validator set is always the same, but the goal over time is that basically any user would be a validator at random. And so the more users you have, like the more security you have. That now, because the size relatively isn't changing, you do need, I think there's just basic math that if you're moving a lot of throughput around a network, you need relay nodes that are doing that, and then also you need archival nodes over time. I've seen kind of a couple things in here around catching up nodes and data storage, and we think that if you look at in Algorand, like fast catch up checkpoint stats, so not everyone has to go back to Genesis and store everything. So I think there's some practical considerations in here, but there's certainly more than one way to skin the cat, and I don't think it necessarily needs to be the case either that having a large validator set slows things down. I do think it can be done. If you look at the way we do it in Algorand, it's a consistent size even as the number goes up. I do think you need to be able to circulate blocks quickly, and that performance will be referential to that at some point. But those things can be disconnected from each other, and you can pick up I think additional performance in that separation of these different layers, even within layer one, in ways that are pragmatic.
Great, yeah. I think we're all kind of keep on hearing the word TPS come up. So why don't we just go ahead and chat about it? So I think one of the things Gun's been kind of mentioning is this whole goosing the numbers thing. And I think TPS, when we looked at it, it's just a really hard thing at this point to kind of objectively analyze. So I guess do you see like down the, because you got like different estimates, different classifications of transactions, and then we have this whole question of like L2s and kind of what that means for throughput. So is there going to be a point in time where, you know, a year from now or 2 years from now that we have some objective way of analyzing this stuff before we get to a point where like gas fees are spiking?
Yes, absolutely. So let me set everybody on the same stage. Suppose, let me tell you about how one gooses these numbers, because I've watched it happen in academia. Every academic knows all the tricks, and in the blockchain space, we're not seeing all the tricks. So anyway, but let me tell you how you cheat at this game. Suppose you have the world's slowest protocol. It can barely make one decision per day. Okay, you could do two things. You could say, look, I've got the world's slowest protocol. It makes one decision per day. I kind of suck at life. I mean, this is an option, and nobody will do that, right? So what do? Well, what you do is you wait all day, and instead of making a single decision at the end of the day on one transaction, you pack everything you've got, and you make one decision again, because that's all you can do. You make one decision, but you make it on a giant batch of transactions. You take the phone book, and you say, at the end of the day, I'm deciding on all of this crap all at once. And so suddenly, you know, you still have the same system. It's making one decision, but it's deciding on a Merkle tree of transactions that's yay big. And you pack as many transactions there as you like. The sky's the limit because you're batching all of these things. And so now you're going to say, hey, look, I packed 100 billion gazillion transactions, and now I'm making 100 billion gazillion transactions per day. Your system is no more usable than it was. If somebody submitted a transaction, they had to wait a day, and now they still wait a day. So the TPS numbers are completely bogus for just about everybody who reports them. And, you know, and people who goose the numbers on something as basic as nodes, they're going to end up goosing all the other numbers, I'm afraid. So we really have to improve the state of conduct in the space. If we don't self-police, I have seen this happen in the database space. It will happen for us as well. We have to self-police, and we have to say, no, don't be doing this. We all know the tricks. And if we start playing these tricks, all the numbers become meaningless. And for the viewers out there, the thing to look at is not TPS. It's the inverse of TPS. Look for time to finality. So if somebody says, well, look, I'm making 1 billion transactions per second, except it takes me a day to do that, well, then that's really not a very usable system. So the thing that we need to look at is latency. That's the one number that nobody can easily mess with. It's very hard to goose. All of us are quite capable. If you leave me alone, I can improve my own numbers by about 1 million. It's like the only thing that's keeping me back is my own honesty. And so I know all of these fine gentlemen and their incredible teams are perfectly capable of goosing all of the numbers. But the one thing that I cannot goose is the time to latency. And I challenge everybody to report that. When you look at that, there's a very clear distinction between the protocols.
I mean, I'd push back a little bit on the goosing in the sense that, you know, if you have one transaction every day, which is batched, and you can put 1 billion transactions, you don't necessarily have the shared security if your data availability happens, you know, off-chain. So if you're in a roll-up context, then, you know, you just need to pay, you know, whatever it is, 10 bytes per transaction, and this is unavoidable, and you're going to be constrained by the throughput of your blockchain. I mean, I do agree that latency is important besides bandwidth. And it turns out that there are tricks to kind of reduce, to take, you know, the layer 1 latency as a starting point and reduce it down essentially to 0. So one such trick, for example, is to do economic commitments. So you can have in a roll-up, you know, the block proposer who can accept transactions and cryptographically sign a message saying, I will promise to include your transaction in my block. And if I don't do so, I'm going to lose $1 billion that I put at stake. And so you effectively have, you know, zero latency. It's economic latency. It's kind of economic finality in the sense that you have this $1 billion at stake. And that's kind of an interesting technique to reduce latency.
I don't know if anyone else had anything to add. I guess maybe we could also just kind of talk. I know you've been talking a lot about latency, finality. Maybe we can just kind of walk through this kind of two different approaches that folks are taking, kind of this liveness versus safety trade-off. So I don't know if anyone has any. I know, Steve, you have some pretty strong opinions on this one, if you want to go.
I think I'm not muted. Sorry. Yeah, I mean, I think that it's not really a choice per se. I think, we believe really strongly that, you need scalability, security, and decentralization, but that in all cases, people can't lose money. And we think that these chains need to run perpetually. And I think that's part of the reason why decentralization is important. But then, in addition to that, they need to, if there are attacks, they need to degrade in a way that's graceful. And I think that that's very, very important. So I think that, there's a lot of discussion here, and I think Emin is right that time to finality is an important metric that needs to be captured. I also think really understanding what happens when networks are under attack is also important. I think, we are starting to see, I think in a lot of cases, if you look at the minor extractable value, reordering of blocks and things like that, these are first-class problems that are now coming to, different style of chains. And that knowing not only that something is final, but what's going to happen when there are attacks on chains, I think is critically important. And so, I think if you look at some of these ideas on, if you know who the next proposer is going to be, that's sort of a theoretical attack, but not one that gets done a lot. And proof of work, if you mount a 51% attack, that's something that's been possible, but happening a little bit more on smaller chains. And I think people are thinking cleverly about it. So I think what's starting to happen now is as economic value increases, it's more when, not if, attacks will come. And so the way we think about it is, one, when a transaction enters a block, it should be final and unchangeable under any circumstances. And then two, and that should happen as quickly as possible. But I think two, when a network is attacked, it should still be alive and run. It should just, gracefully degrade. And so during the period when you're under attack, you may have lower transactions per second. You may not have blocks being produced every single, every round, but that you'll never have anything that affects finality. And so I think at Algorand, that's what we've really focused on, is making sure that, the chain runs all the time and understanding what the performance characteristics are when the chain is under attack, because these networks certainly are going to become under attack more. And so I think that's, I would encourage anybody who's interested to go look at some of Sylvia's writings in these areas. I think he's, I think he's a very thoughtful guy, and there's a lot of interesting research and technology that's put into those elements. And I think that's, for us, critically important. And, I guess that's all I got on that one.
So, yeah, I think Steve points out a very interesting issue. And let me describe how Avalanche differs from every other protocol in this regard. So all of the protocols that are other than Avalanche have what we call a deterministic approach to consensus, and as a result, the attack threshold against them is very well defined, and that has some interesting implications, and I want to describe what that means. So take any BFT protocol. And typically they have a 33% threshold. If the attacker is 32% big, he has no power whatsoever. He might degrade the system, etc., but he won't be able to cause a safety problem. If the attacker is 34%, then he is guaranteed to win and bring the system, cause a double spend within the system.
He still needs to partition the network, though.
Let's not get into the details, but we can try to define the things. But the important point is there's a very well defined threshold for the attacker to succeed, and they know exactly when they will succeed prior to launching the attack. These attacks don't get launched at 1% and you build on it and you build on it. If you're a smart attacker, you amass your 34%, do your attack, and go home. Avalanche is different. It's a probabilistic protocol, and it can be parameterized for any safety level. And suppose it's been parameterized for 33%. Suppose we do exactly, we request the same threshold of safety. What that means is that the probability of a double spend at that level of attack meets a certain guaranteed target. Something like, you're going to see a potential double spend with an attacker of size 33% only once in 20,000 years. Okay. Now, what happens if the attacker is a little bigger? That's an interesting question. Unlike classical protocols, the way Avalanche works is entirely different. And so when the attacker is bigger than the threshold, it's true that we no longer make the initial guarantee that we set out to make. The attacker will be successful more often than once in 20,000 years. But how much more often is that going to be? It's not immediate. It might go from once every 20,000 years to once every 10,000 years, which is terrible because we blew through our guarantee. But it's still not as bad as he is guaranteed to win. And in fact, if you look for an attacker against Avalanche to meaningfully succeed, that is to have more than, say, 60% chance of doing a double spend, they have to have enormous amounts of stake. So the economic security of a protocol, of a superior protocol that uses, essentially the probabilistic metastable consensus algorithm behind Avalanche is very different from classical algorithms. So I'm really excited about this. This has a lot of implications, both economically and also for protocol design. And we're looking forward to expanding on this in our research team.
Okay. All right. I don't know if anyone wants to respond quickly, but if not, we'll just move on to the next topic. I think one of the things we want to talk about is, so I think Steve and Anatoly brought up earlier the question of fees. And I think when we think about like the tokens, there's kind of a couple different things, like like what the token is used for, whether it be staking, paying fees, or even governance. And then there's this other kind of thing going on the fee side where like, where do the fees go kind of once they're paid, right? So I know, Justin, you've done a ton of work on the EIP 1559. So maybe if you want to kind of walk us through briefly how you see that shaking out to start it off. So
is the question around, can you rephrase the question? Like,
I guess it would be just, so I guess in the short term and the longer term, what do you see as like the main driver of token value, right? Like, it's pretty comparable narrative right now with this EIP 1559 change.
Right. Okay. So I guess there's the fundamentals, which is basically supply and demand. So in terms of supply, we effectively have a kind of essentially a fixed supply. So we're going to peak at 120 million ETH. We might go down a little bit in supply, but it's very different from a fiat currency where we have exponential growth every year. Let's say 2% or 3% or whatever, 5% every year. So that's kind of the typical blockchain context where you have a very good control over the supply. In terms of demand, there's kind of three demand engines for ETH that I see. Demand engine number one is staking. So we have around 7 million ETH, which is demanded for staking, and that is expected to grow partly because post merge the part of the fees which is not burnt is going to go to the stakers. And so my rough estimate is that we're going to have, let's say, 30, 40, maybe even 50 million ETH staked. So roughly half of the ETH will be staked. Another interesting kind of demand engine is DeFi. So when you want to do DeFi, you want to have collateral at stake. And this collateral, needs to be as trustless as possible. And it turns out that the best form of collateral, the most trustless in the context of Ethereum is ETH. And so today, roughly 10 million ETH is demanded as collateral for DeFi. So that's the second engine. And then the final demand engine is the transaction fee. So people want to have access to this scarce resource, which is Ethereum block space or kind of gas space, and they're paying a lot for that. They're paying around $10 to $20 million every single day. And with EIP 1559, what we've managed to do is kind of turn transactional utility into demand for ETH. And the way that that this manifests itself is basically canceling the issuance, which is diluting which is basically adding to the ETH supply. But I think that's kind of the fundamentals. But there's something else which is much, much more powerful than the fundamentals, and that is narrative. And the reason is that money is largely an illusion. Money is what I call a money candidate with a monetary premium. And so the idea of monetary premium is this magic meme energy where society somehow comes to consensus around one asset being worthy of monetary premium. So people already do that for assets like gold or like Bitcoin or fiat currencies. And I think there is a potential for ETH to gain a huge amount of monetary premium. Now, how do we achieve monetary premium? We do that through a monetary Schelling point. So you need to have an asset which, in some way or another, distinguishes itself from the crowd. And we have aspects like programmability, which maybe used to be helpful for the monetary premium, but now we're in the context where there's lots of programmable blockchains. Maybe we could look at economic security, right? I already mentioned we have $21 billion of economic security. You can look at all these various things and ask yourself, is this asset worthy of monetary premium? And my guess is that as it stands, Ethereum is the #1 candidate to become the money for the internet, and hence achieve monetary premium on top of the basic fundamentals.
So let me describe how we see this. The Avalanche coin has multiple uses, and I think the standard for just about everybody in this game is the coin is useful for doing basic things in the network, like carrying out transactions. We burn all of our fees. I think congrats to the Ethereum community for enabling 1559. It's a great idea. We've been enjoying it for some time. It's fantastic to turn the transactional usage to benefits for every coin holder. It's a very, very good idea. The second thing that everybody does is uses the coin for securing the network, like Justin mentioned. So that's done via staking. And one difference between Avalanche and quite a few others is that there's no slashing in Avalanche. So in case you happen to delegate or validate with something with some node that misbehaves for whatever reason, there is no risk of funds loss. This is quite big. And I think I want everybody to think about that, because you don't want your actual savings or whatever it is that you've got there to disappear because of a software bug or a hardware bug, as can happen. But the third, and I think one of the most interesting things about the Avalanche system, is this notion of subnets. We are not just a single network. It's not a single coin, single network, single virtual machine kind of a system. We do have the underlying coin, but we have many different virtual machines, and we envision having many different subnets. Each and every one of these subnets can power a different use case. And if you look into enterprises, they all want the performance isolation when they launch their own systems. The only way to get that performance isolation is by having your own subnet. And creating these subnets requires demand for a Vox. And that's one of the unique ways in which there's going to be more demand for a Vox going forward as subnets become more popular.
I'll go next. So Solana right now is set up. We kind of like looked at the wind and thought, okay, maybe this won't be the most broken fee model. That was basically burn half the fees to prevent spam, right? Like 100% of the fees, and they'll just arbitrarily spam the network. And the reason for the token is really to prevent spam on the network. That's really the fundamental thing that it does. If you think of the network as a censorship-resistant message bus, that's the only thing that it does at the end of the day. And staking and all these other things kind of derive from that. How do we ensure that it's censorship resistance? How do we maximize that Nakamoto coefficient? And this is where my opinions with Emin. Flashing is a stick that can be effective in maximizing censorship resistance, because some of the reasons why a user may not want to stake with a single validator and may want to distribute the risk and analyze that the risk is truly distributed because they've done the analysis and done effectively the real world Sybil checks. Hey, are these actually different validators with different key management with that are doing a good job in that sense? That could be a very important stick, right? From a design perspective, to force people to do that. It's still unknown whether any of these economics will really work until the system is has so much usage that we see the kind of effects that you see in Ethereum one today, where it's under load and you actually get to deploy something like 1559 and see the effects of that. Because the user load is so low right now, it's basically kind of like anything that we do will look like it's working. But the stuff actually only is testable under extreme conditions with real world, effectively attackers and folks trying to break it and maximize their economic returns.
I think I'll just add one thing to this. I mean, I think there's a bunch of valid points. My take is that, if you look at what tokens are used for internal to the system, there's a number of different things. So certainly, transaction fees are a deterrent to, DDoS attempts and take up a valuable thing. And I totally agree that, like, making sure the message bus continues and transactions flow normally is important. I also do think there are other key uses. If you look at things like, smart contract fees, minimum balances for people creating assets, again, those are all attempts at, keeping people from doing wasteful things on chain and ascribing economic value so that they're not going to spam the network with, useless wallets and other stuff like that. I think that goes there is sort of a step further, where if you look at governance and you look at, kind of why you would want to have tokens staked and kind of online in a network, as we start to see larger scale deployments, on the scale of, countries or larger institutions, I think that their desire to have a role in governance and have some influence over, future technical development and other things is something that we're going to see more of. And so I think, definitely if you look at Algorand, there's a new governance system that's going into place in October that will effectively hand over not just, protocol updates, but, many other updates around kind of the use of tokens into the hands of the community. And we think that that's, we think that that's really, really key. So again, I think there's a variety of different ways, but I do think at some fundamental level, like the native token is something that, serves a bunch of different purposes, but fundamentally they all revolve around both kind of security of the network and also around ongoing kind of evolution of the network and governance of it for different reasons. But I think that, getting those incentives right. So Anatoly, I totally agree with you. Getting incentives right is super important, and you could put almost anything in at small scale, and you'll never know if it's going right because someone will decide it's right and someone will decide it's wrong. I think it's at scale that you start to, some of these things start to reveal themselves a lot more, and I think it's be interesting to watch as these things flesh out over time.
Awesome. Yeah, I think we're pretty tight on time, but I guess the one last question I've had. So if you look at these platforms, they're all obviously general purpose platforms for the most part. So I think DEXs and NFTs have kind of dominated the narrative and chewed up a lot of the gas the past year or so. I guess over the next couple of years, are there any things you guys think that are probable applications that we'll see that we haven't seen to date that are going to become popular? It's a tough one.
So this is like predicting Facebook in 1994.
Exactly.
Right? Like, who would have believed that sharing pictures of cats with your family is going to be worth $1 trillion? It's so hard.
Yeah.
What I'm excited about is it feels like this cycle is really the start of an inflection point where we should see, the first 100 million people with self-custody actually using these platforms. And the kind of applications that grow within that network, right? Truly self-custody, decentralized applications that don't touch any central systems, that are not in a, some single app sandbox. What those will look like, this is what I'm building for, right? I really want to see those experiments play out and see what works.
So I guess the question here is, what's the killer app for blockchains? I get this question a lot, and if I used to get this question also in the 90s when people were just sort of grappling with the internet, and they're like, what's the killer app for the internet? And when they ask this question, people typically want to hear something futuristic. They want to hear oh, we're going to be on Mars and we're going to transact with blockchains and da 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 da. And sure, I mean, that's going to happen. I do believe that that's definitely the future, but that's silly. The killer app for the internet was the very first app. It was simple person-to-person communication. The killer app for blockchains is the very first app, which is creating a digital asset. Now, there's big differences between visions. So there are lots of people out there with a single network, single asset, and they're competing against the dollar's dominance. They're competing against the euro's dominance. That is not the vision with us. We are not trying to compete with USD versus euro versus whatever else. We are trying to create a platform on which anybody can create their own asset and then open it up for global digital trade. And I think that is so compelling. Anybody, ask anyone who's created an NFT, or ask yourself why NFTs became so successful among all your normal friends. They're not even crypto heads. They don't know what, whatever modular exponentiation is, and yet it turned people on. It's so compelling, and the space is so huge that there is room in it for many different approaches to blockchains. So I'm absolutely thrilled to be surrounded by these efforts, and they're all respectable, reasonable efforts within the same, attacking the same big problem. And the problem is so big, and the opportunity is so large that it doesn't have to be any fancier than that. Digitize everything and allow people to transact with it.
I think I would just add one last thing, which is I'm not so much in the prediction game. I think we're starting to see the building blocks that people use to build new applications, and I think that meaningfully they're all going to be built on public blockchains like the ones represented here. So obviously we want as many developers to build on Algorand as possible. I know everyone else wants the same, and I think it'll be interesting to see how things shake out. But I think if you liken this to the early days of the internet, there were a whole bunch of internet service providers early on, and that forms kind of a public fabric that everybody uses every day. And I think it's pretty likely that the chains represented here will be part of a big public network that virtually the whole world uses every day. And how that shakes out over the next little bit, be interesting to see.
Yeah, I agree with Anatoly that it's kind of very difficult to predict, and kind of the beauty of it is that you can't predict. It's kind of like a child at Christmas. You don't know what you're going to get. And NFTs was kind of an example of that. I mean, two of the advantages I think Ethereum has kind of in this space is, one, because we already have existing applications, and because composabilities can be extremely valuable. We have these network effects. So because we already have DeFi, for example, if you're going to build a new DeFi block, it makes sense to leverage a stablecoin or a lending platform or whatever it is that already exists. I think another kind of interesting point is the culture. Going back to layer 0 and the community. Like, do you have a culture around innovation and building? And I think Ethereum is kind of, in a sense, unique in that space, is that we have a very, very strong culture of building and entrepreneurship and things like that. So yeah, I'm very, very excited to see what these builders build in the years to come.
Awesome. Well, thank all of you. It's been excellent. Really appreciate you taking the time to come on with us, and yeah, we'll see you next time. We'll wrap things up.
Thank you.
Thank you, everybody.
Bye.
Okay.
Right. Thank you, guys. Take care.